So yesterday we started 5.5 solving polynomial equations, but what we really did yesterday was just reviewed all the different factoring methods that we already knew about, because we need to know those factoring methods from chapter 4 to be able to apply those factoring methods today when we do equations that are polynomial equations, right? So go ahead and in your notebooks write down day 2. Day 2, solving polynomial equations. So once again, we reviewed all the different factoring methods, pulling out the GCF. We reviewed factoring by grouping. We reviewed the shortcut of factoring when your a value is not 1. We did the difference of two squares. That's a good one. We also learned about the sum of two cubes and difference of two cubes. And why do we want to factor? So ultimately, when we're solving equations, we could factor and then split them with the zero product property and solve. So if we look at number 1 right here, this is going to be, go ahead and copy down number 1 right there. It says solve by rewriting it as a quadratic. Don't copy down number 2 yet, because you're definitely going to need a lot more space than what I have right here. Now, the problem with this is this equation is a quartic. If it were a quadratic trinomial, I'd be able to solve it at the very least by applying the quadratic formula or by doing some type of factoring method, right? But it's not a quadratic, it's a quartic. So right here on the instructions, I specifically tell you solve by rewriting it as a quadratic. So I would like a quadratic trinomial that's ax squared plus bx plus c. That way I could factor, split, and solve, or use a quadratic formula. Now, the idea is this. This is not a power of 2, but what I'm going to do is I'm going to rewrite it as if it were a power of 2. So the a to the 4th, I'm going to rewrite it as a power of 2. So what do I have to have in here? So when I do the power of 2, I end up with a to the 4th.
6 squared.
And you know what? You can't put the 6 in there, because if you do 6 in there squared, it'll become 36. So how about this? Let's keep the 6 out here in front. And what belongs in the parenthesis?
A squared.
A squared. Perfect, because a squared squared, power to a power, you multiply. That's how you end up with 6a to the 4th. Now, this other one, minus 7, now it is an a squared, but you know what? Just so you could clearly see what I'm doing here, I'm going to put parentheses and put that a squared in the parentheses. That's totally unnecessary, but I want you to see what's happening here. What is happening here? This now looks like a quadratic trinomial equation, doesn't it? Where your a, your b, and your c are right there. This is your x squared term. This is your x, your bx, and this is your c. Now, if you're still like, wait a minute, I'm still confused. If you're a little confused, you could do this. You could substitute x for a squared. Let me put the a squared in blue since it was in blue already. So if you wanted to, you could substitute this for your own understanding. If you're good with this, you could just keep going. But if you want to, you could substitute the a squared, the x for the a squared. That way it'll really look like this. 6x squared minus 7x plus 1 equals 0. What do you guys think? Do you guys understand what I did at least? Yeah? I forced this to look like a quadratic trinomial. It's like 6x squared minus 7x plus 1. Now I could actually solve this either by using the quadratic formula or by using some type of factoring method. So what do you guys say? Do you want to use a quadratic formula, or do you want to try to factor, split, and solve? Factor. Okay, let's try to factor. It never hurts to try, right? And if it doesn't work, then you could always go back to the quadratic formula. But notice that the a value is 6. It's not 1. So I'm going to have to use that long method, or the magical shortcut. Step 1 is going to be the same, a times c. What's a times c? 6. And then we got to think of the multiples of 6 that combine together to give us the middle value, which happens to be negative 7. So when I make my list, it's either 1 times 6 or 2 times 3. So which pair of numbers, when I combine them, gives me negative 7?
Negative 1 and negative 6.
Yeah, negative 1 and negative 6. 1 and 6 gives us 7. We have the right numbers, we just have the wrong signs. We want a negative 7, so make those both negative. And step 3 on this factoring method is to write your factored format with the AX term first. And notice we're going from here, right? The AX is 6x and 6x. And what do we put in these blank spots right here? The -1 and the -6 go right in there. Thank you. Ladies and gentlemen, that's barely step 3. Step 4 is to magically reduce, divide by whatever you can. On the first binomial, could you divide by anything? No. 6 and 1, there's nothing to divide by, so just bring it down. In the second binomial, could you divide by anything? Yeah, by 6. So it's going to be a 1x minus 1. Ladies and gentlemen, that's factoring. Now, why do we want to factor? Because this was equal to 0 at the start, which means that this is still equal to 0. And now we could apply the zero product property. Okay? The zero product property is 6x minus 1 equals 0. X minus 1 equals 0. So we're going to get two answers. Plus 1 plus 1. 6x equals 1. X is going to equal what? 1/6, right? And the other one, plus 1 plus 1, x is going to equal 1. However, if you circle those and you put those as your answers, you're going to be wrong. You know why? Because this was not an equation that had x to start with, right? What did we do? We made it look like a quadratic by replacing the a squares with x. We substituted x so it could look like a squared, so it could look like a quadratic. So we just got the answers to x. But what is x really? X is really a squared. So I need to go back and replace those x's with a squares. So let's do that. Let's replace, instead of x equals 1/6, we're going to put a squared equals 1/6. Instead of x equals 1, we're going to put a squared equals 1. And ladies and gentlemen, we have two quadratic equations that we still need to solve. So when I solve this, I'm going to square root, a equals plus or minus the square root of 1/6. Technically, you could reduce that further, but I'm just going to leave it like that. I don't want to confuse you guys anymore. Square root, a equals plus or minus the square root of 1 is 1. So right here, we actually have 4 answers for this quartic equation. The original equation was to the 4th power. We got 4 answers. They are 4 real answers. If you were to graph this guy, because the leading coefficient is positive, your end behavior would be up on top on quadrant 1 and quadrant 2. And it will cross the x-axis 4 times. It'll cross at 1, it'll cross at -1, and if you do this on the calculator, it'll give you a decimal value, and that's the location of where it would cross also, just to let you know. So there is a benefit, to changing a quartic or a 6th degree or 8th degree back to a quadratic so you could apply factoring methods that you already knew. Like number 2, go ahead and jot down number 2 now. That's a quartic binomial. And I'm looking at this thing and I'm seeing a minus sign between 2 terms. And in my mind, I start thinking of the difference of 2 squares. You guys remember difference of 2 squares? We did that yesterday. Difference of 2 squares is this guy right here. A squared minus b squared equals a plus b, a minus b. So if it were a difference of 2 squares, it'd be pretty easy. It would just be parenthesis 1 plus 1 minus, and you plug in your values in there into the factored form answer. So I'm going to force this, I'm going to try to force this, try to make this look like a quadratic instead of a quartic. So could I change that m to the 4th to something squared? Yes. What would that be? M squared. Okay. And here's another one. Could I, and if I can't, then I'm stuck, all right? Could I change 625 to be something squared? 25, huh? So, ladies and gentlemen, we took this quartic equation and rewrote it as a quadratic equation. And it's great because it's already in the difference of 2 squares. So now we could actually factor, and we'll get parenthesis, and one's going to be a plus, and one's going to be a minus. And what belongs in those? m squared with the 25, m squared with the 25. You guys remember that? Difference of two squares. All you got to do, if you already set it up as a squared minus b squared, then you just put the parentheses, you put plus, you put minus, you put your a right there and your b right there. Put your a right there and your b right there. So we made this look like a quadratic. And now we got to look inside each of these binomials, inside each of these parentheses, and see, could I continue factoring? And m squared plus 25, you can't really factor it. But m squared minus 25, that's actually a difference of two squares again. So that second parenthesis could be broken down even further to what? Plus 5, m minus 5. All right, good. And we still have that first parenthesis, the m squared plus 25. We couldn't do anything right there because there was a plus. So we have completely factored. We changed this quartic binomial. We changed it to this mess right here, a quadratic binomial times a linear binomial times a linear binomial. But it is equal to 0. And now we're going to apply zero product property to solve each of these. So when I have something times something times something, this first something could be 0, the second something could be 0, and the third something could be 0. So I have m squared plus 25, that could be equal to 0. I also have m plus 5, that could be equal to 0. And I also have m minus 5, that could be equal to 0. So I need to solve each of these and I'll get my many answers to this quartic equation. So when I solve this first one, man, I'm running out of space. You guys are writing this in your notebook. You have plenty of space. On this first one, we're going to subtract 25, subtract 25. We're going to end up with m squared equals negative 25. And then what? Square root, square root. When you apply a square root in an equation, you must put a plus or minus in front of your answer. And the square root of negative 25, it is a perfect square number, but it's a negative. So what's our final answer going to be? 5 with an I. Remember, that negative becomes an I on the outside. And this, ladies and gentlemen, is two answers. But we still need to go through these other ones. The m plus 5 equals 0. You subtract 5, you'll have m equals negative 5. That's another answer. Then over here, m minus 5, you go plus 5, m equals positive 5. That's another answer. So we actually got 4 answers for this quartic binomial equation. 2 of them are real and 2 of them are imaginary. So how about this? Just to relate it to polynomial graphs. What kind of end behavior am I going to have? Because it's an even degree function, they're both going to go where? End behavior. Up. Both of them are going to end up in quadrant 1 and quadrant 2. And also, how many times will it actually cross the x-axis? 2. Because why? It has 2 real answers. It has the negative 5 and the positive 5. Like, those are actual locations on the x-axis. But when you're talking about I, that means that it doesn't really, it's not a real x-intercept, it's an imaginary x-intercept somewhere else. So it only crosses 2 times, but it does have 4 answers. 2 are real, 1's imaginary. Okay, so as you can see, we are applying old factoring methods on this new stuff with higher degree polynomials. Let's look at our worksheet. Our homework for today is to do 2 through 18 even, and then 19 through 25 all. So we are using all kinds of factoring methods to do these. Let's take a look at number 2. What factoring method should you always start with? You could, yeah, I would rewrite it in your notebook because you're not going to have much space. Actually, these first ones are pretty easy and pretty quick, but there's other ones that are longer. So if you want, do number 2 on your worksheet. But what should I do? What's the first type of factoring I should try? Pull out a GCF. So everybody put parentheses like right there. And what is in common with the 3, the 9, and the 6? 3. The multiple of 3, yeah, you could divide them all by 3. And how about, is there S's in all the terms? Yeah, the maximum amount of S's I could pull out is 1. And then how about T's? Is there T's in all the terms? Yeah, there's t squared, there's 1t, and there's 2 t's. What's the maximum amount of t's? 1. So what would be left over on the inside? That would be a t, and then minus what? 3 s squared, and then plus 2 s t. There you go. Is there anything else to do inside of the parentheses? No, there's nothing else to do. We're done. And if you flip the paper over, you'll see that that's a correct answer. It's just pulling out a GCF. The next one that you do should be pretty much identical to that one. So I'm not going to do number 4. It's the same thing. Pull out a GCF and you're done. Let's jump to number 6. So I want to do a couple, and I want you to do a couple. Number 6. Could I pull out a GCF? No. X, X, X. Oh, man, there's no X. How about 2's? No, 2, 2, there's no 2's. What the heck do I do? What's the second type of factoring that we should try to do if GCF doesn't work?
Both parentheses.
Grouping. Yeah?
Yeah.
Grouping. So let's first separate it into 2 groups. You're going to have x squared minus xy space plus 2x minus 2y. In the first group, what could I pull out? X. What would be left over on the inside?
X minus y.
Okay, and in the second group, what could I pull out? 2. And if I pull out that 2, what's going to be left over? X minus y. Thank goodness, because now we have that common binomial, x minus y, that could be pulled out of the whole thing. That's exactly what you do on factoring by grouping. You pull out that common binomial of x minus y, and what we have left is the x and the plus 2. So your final factored form is x minus y, x plus 2. This is pretty much just a review of what we've already done. So that's number 6. Number 8 is pretty much the same thing. It's factoring by grouping, so you guys could do number 8. Let's jump to number 10. 10 is just a review of chapter 4 also. You want to factor this, but the a value is 6. So what do? A times c, what do you get? Negative 18. Step 2, make the multiples of negative 18. Make a list. Negative 1 times 18, negative 2 times 9, negative 3 times 6. And then you ask yourself, which pair of numbers combines together to give you the middle value, positive 7?
9 times negative 2.
9 times negative 2 is right. Now you could change it to a polynomial and do factoring by grouping, or the quicker method is to jump right into the factored form format with ax right there and ax right there. You plug in the values from step 2 right in here and right there. Then after that, you divide by whatever you can. You magically divide. So you're going to end up with dividing by 2, 3x minus 1, and this one dividing by 3, you'd get 2x plus 3. And that's it. So nothing new right there. That's still from chapter 4. Now this next part is, I'm sorry, do you guys need more time on that? No? This next part is the newer part, where it says write each expression in quadratic form if possible. Okay? So we're just practicing a certain skill right here. We're taking a quartic and seeing if we could rewrite it as a quadratic. So the question is, could I change that b to the 4th to look like something squared? And what would be on the inside of the parentheses? And notice the 10, I'm just going to leave it out here. I'm not even going to mess with 10. That'll be my a value if I'm able to change it to a quadratic trinomial equation. So inside, what do I have left? B squared. So when you do this, it's important that you verify that this other term is also b squared. If this guy is not the same as this guy, then it's not really going to work. It's not a quadratic. You're not going to be able to rewrite it as a quadratic. Does that kind of make sense? So this guy, you're going to put it as 3, and there's no need for the parentheses, but I'm going to do it just so you could see what I'm doing here with the minus 11. That is a quadratic equation right there. I mean, the whole purpose of this is if this were an equation, let's say it had an equal 0, yeah? Let's say it had an equal 0. Then you could do this, and then you could replace these guys with x, and it'll look like a quadratic trinomial equation, 10x squared plus 3x minus 11. And then you could use the quadratic formula, get some answers, and whatever your answers are, like x equals this, x equals that, you'd have to replace your x's with b squares, then you'd have to apply a square root to get your final answers. But we're not even there yet. Right now we're just practicing changing a fourth degree or a sixth degree or an eighth degree back down to a quadratic. So that is able to be changed. But when we look at this one right here, are we able to change this one to a quadratic? The answer is no. Why not? Because if I change this to something squared, it'll be x to the fourth squared, right? X to the fourth in parentheses. But see, this is not an x to the fourth. So in order for you to do this little trick, whatever this degree is, this one has to be half of it. That's just a fact right there. If not, you're not going to be able to do it. Does that make sense? No? Yes? Okay. Again, let me just show you. If you tried to do this, put that minus 5 on the outside, what would be in there? It would be an x to the fourth. And if you had a plus, and over here, it's not an x to the fourth. It's not an x to the fourth. It's an x squared. So it's no longer ax squared plus 1x. It's ax squared plus 1y. It's something different. This is an x to the fourth. That's an x squared. You can't do it. So in order to apply this trick, you have to make sure that this middle degree is actually half of this bigger degree.
So what happens when it's not? What do we put?
You just say no. Because the instructions on this one say, write each expression in quadratic form if possible. You just say not possible. It's not possible. I don't know, should we do more of these, or what do you think? Number 15? Okay, so I need to change this to a quadratic. A quadratic. Now, what is a quadratic? It's something squared. So, again, the 28, the coefficient, we're just going to leave it out here, 28. But could I change d to the 6th to be something squared? Yes, what would it be?
D squared.
D squared?
3.
D cubed, right? Power to a power, you multiply. And so, is this a good thing, that this is a d cubed? Yeah, why? Because this one's a d cubed. So, absolutely, this is now a quadratic. And the c value would be plus 0 if you want, right? So this is just practice. Practice what for, so when we get to actual equations, you'll be able to substitute and solve. So let's go over here to solving each equation. I don't know. Should we do 19, 20? Yeah, let's just go with 19. Why not? All right. So what could we do here? What should we do? What's the first type of factoring we should do?
GCF.
GCF. Okay, so what is a GCF?
Y squared.
Y squared. Y squared, what would we have left over?
Y squared.
What else? Minus what?
71.
And then?
18.
Minus 18. And of course, this is still equal to 0. We'll put that equal to 0 at the very end. Let's just look at the inside and see if we could continue factoring. See, in blue right here, we have a quadratic trinomial that has an a value of 1. So maybe we're able to do this. What times what is negative 18 that if you combine together is negative 7? Negative 9 and 2. It does work. Bring down the y squared. And that's as far as you could factor. And this is an equation that's equal to 0. So let's put that equal to 0 right there. And we have used these different factoring methods to be able to get it factored to now split and set each of them equal to 0 using the 0 product property. So y squared, that could be equal to 0. Y minus 9, that could be equal to 0. Y plus 2, that could be equal to 0. So you need to solve these guys. When you solve this one, you square root, you get y equals plus or minus 0. So the answer is just y equals 0. The other answer is going to be y equals 9. The other answer is going to be y equals negative 2. So this was a fourth degree equation, and we actually got 4 answers, even though at the end of it all it's just 3. Now the reason why I said we have 4 answers is because there was duplicity on the 0, right? The 0, positive 0 is one answer, negative 0 is one answer. It's technically two answers, but it's the same answer, so you just write it once. So what would this mean visually? Visually means it's the even degree means that the end behavior is both in quadrant 1 and quadrant 2. And it's going to be some squiggly lines. It will cross the x-axis at 9, at -2, and it'll just touch at 0. Okay? Let's move on. I don't know. Let me see which one we should do. Let's take a look at number 21. Any ideas on 21? Can't pull out a GCF. If we had a squared term and a squared term, it'd be a difference of 2 squares. You guys remember difference of 2 squares? A squared minus B squared, you could just rewrite it as AB, 1 plus 1 minus. You guys remember that, right? But it's not something squared minus something squared. It's something to the 4th minus a number. So the question is, could I rewrite this as a quadratic, as something squared minus something squared? Well, I know m to the 4th. That would work. What would be inside the parentheses?
M to the second.
M to the 2nd. Now, the tricky one is 625 a perfect square number? What is that? What's the square to 625? 25. So it does work out great. So this is our difference of 2 squares, the difference of 2 squares. So now we could actually rewrite it as the binomial times the binomial, 1's plus, 1's minus. In the first one, you have your m squared with the 25. In the second one, you have your m squared with the 25 as well, but it's a minus. We have factored it. We cannot continue factoring here because these are perfect square terms, but it's a plus. You can't do that when it's a plus. But right here, it's a minus, which means you could continue factoring. So you're going to have what? M plus 5, m minus 5. And over here, this one stays m squared plus 25. Now, why would we factor? Because this originally was an equation that's equal to 0. It's still an equation equal to 0, which means now we could split them all up. We're going to have m squared plus 25 could be equal to 0. M plus 5 could be equal to 0. And m minus 5 could be equal to 0. So we have 3 equations that we need to solve. That first equation, m plus 25 equals 0, when you subtract 25 on both sides, you're going to end up with m squared equals minus 25. And then when you apply a square root, you'll get m equals plus or minus. The square root of 25 is 5, but there's a negative in there, so you're going to get a 5i. And on the other ones, you're going to go minus 5, minus 5. You're going to get m equals negative 5. You're going to go plus 5, plus 5. M equals positive 5. So you get 4 different answers. 2 of them are real, 2 of them are imaginary. So if you look at the back, you're going to get the answer 5, negative 5, positive 5i, and also negative 5i. And that makes total sense. It's a 4th degree equation. It's going to have 4 answers, a maximum of 4 answers. How many times does this graph actually cross the x-axis? Only 2 times, at positive 5 and at negative 5. Fun stuff. Let's get to the really fun stuff here. Let's jump to, like, you're going to do number 22 exactly the same, the difference of 2 squares. Should we do 22, or you guys got it? You guys got it. 23 is a little bit more fun. What do I mean by 23 is a little bit more fun? This is a trinomial, and to me, I'm thinking it would be great if this were a quadratic trinomial, x squared minus 50x plus 49. But it's not. It's to the 4th. So I'm going to make it look like a quadratic by doing this. And what's in there? X squared. And then over here, we have the minus 50, and I'm just going to put it in parentheses so nobody gets confused, even though it's totally unnecessary to put it in parentheses. And then the plus 49 at the very end equals 0. So if you wanted to, you could substitute, put a regular x right here and a regular x right there, but when you get your answers, you're going to have to replace them back with x squares. So we've already done the substitution. Let's try to do it without substituting by keeping it that way. Just look at the red part. It looks like x squared minus 50x plus 49. So let's think this. what times what is 49 that if I combine together is negative 50?
Negative 49 times negative 1.
That's right. What do you think? Now, is anybody confused with this? Normally, I would put like a regular x right here. I would substitute, but I just left them there. You could just leave them there. You don't have to substitute. Now, we factored. Could we factor more because these are x squares? Yeah, we have a difference of 2 squares in each one of them. So on this first one, you're going to have what? Yep, x minus 7x plus 7. And on the second one, you're going to have what?
Plus 1.
X minus 1x plus 1. So we have taken this 4th degree trinomial and factored it as much as possible to the point where we got something times something times something times something. And it is all equal to 0. So we're going to split them all up and get our answers. X minus 7 equals 0, x plus 7 equals 0, x minus 1 equals 0, x plus 1 equals 0. So your answers are going to be x equals positive 7, negative 7, positive 1, and negative 1. Those are the 4 answers to this equation number 23. Fun stuff, right? You guys could do the same for 24. And now 25 is a good one. Physics. A proton in a magnetic field follows the path of a coordinate grid modeled by the function f of x equals x to the 4th minus 2x to the 2nd minus 15. What are the coordinates of the points on the grid where the proton crosses the x-axis? What are they really asking you to do?
Solve it.
To solve it by factoring, right? So if they want the x-intercepts, they're telling you to set y equal to 0, and you just need to solve it. So let's do that. X to the 4th minus 2x squared minus 15. You can put the equal 0 over here. And how would you solve this? By treating it like if it were a quadratic. Right? Now, yes, you could substitute, put like an a right here and an a right there if you want. But then once you get your a answers, you're going to have to plug the x squares back in. So let's do it without substitution. Let's just go for the factoring. Imagine this. X squared minus 2x minus 15. If I did have x squared minus 2x minus 15, I would put an x right here and an x right here. But instead of x's, I'm going to put the x squares right in there. So what times what is negative 15 that if you combine together is negative 2?
Negative 5 plus 3.
Negative 5 times positive 3. And this is factored, but could we factor any further? No, we can't. X squared minus 5, if this were a perfect square term, I would be able to. There's nothing else we could do. And this is equal to 0, which means we're now able to split them and solve. So we're going to have x squared minus 5 equaling 0 and x squared plus 3 equaling 0. So you're really going to have x squared equals 5 and x squared equals negative 3, which means you're going to apply a square root on both, and you'll have x equals plus or minus the square root of 5, and x equals, when you square root both, plus or minus I square root of 3. So those are your 4 answers to this original quartic equation. However, they're asking us for what are the x coordinates. So how many times will this path cross the x-axis? 2 times. These are imaginary, so these don't count. It doesn't actually cross the x-axis. But the square root of 5 in a calculator actually gives you a decimal number. So those decimal numbers will be the 2 locations, one positive, one negative. That'll be the 2 locations of where this proton will cross. So they're asking for it as a coordinate. I'm assuming they actually wrote it as the square root of 5, comma 0, and also negative square root of 5, comma 0. Or maybe they actually did change the square root to decimals. What do they do on the answers?
Negative square root of 5 and 2.
Okay, so they left them as radicals. That's fine. Yeah, so these are the answers. All right, guys, I did a large majority of this homework. You guys could do the rest. The answers are on the back.